On the ACT, when it comes to trigonometry questions, oftentimes the questions will revolve around your knowledge of the unit circle. In this video, we're going to review the basics of the unit circle. The unit circle is a circle centered at the origin with a radius equal to 1. So if we wanted to create a unit circle, we would start at the origin and then go out 1 unit to the right. That would bring us to point 1, 0. Then we would move counterclockwise a full 360 degrees, or if we're using radians, 2 pi radians, in order to complete the picture of the unit circle. You can see in the top left diagram a unit circle with several angles and points mapped out. What the unit circle allows us to do is extend the domain of sine and cosine to all real numbers, rather than just limiting us to between 0 and 90 degrees. The sine of an angle on the unit circle is equal to the y-coordinate of its point on the circle. So if we're looking at the sine of 30 degrees, on the unit circle we would be at the point square root of 3 over 2, 1/2. The y value there is 1/2, so the sine of 30 degrees is 1/2. The cosine of an angle, of course, is then the x-coordinate of its point on the unit circle. So the cosine of 30 degrees would be the square root of 3 over 2. The mnemonic all students take calculus can be used to remember which trig functions are positive in each quadrant. So if you look at the figure in the bottom left, you'll see that we have A, S, T, and C for all students take calculus. The A meaning all functions are positive in quadrant 1. The S in quadrant 2 means that only sine and its reciprocal cosecant are positive. In quadrant 3, we have T, or tangent, so only tangent and its reciprocal cotangent are going to be positive in quadrant 3. And then in quadrant 4, we have C, so only cosine and its reciprocal secant are positive in quadrant 4. When calculating the values of trig functions, you always want to evaluate the angles with respect to the x-axis, and then use all students take calculus to determine whether it's positive or negative. For example, the sine of 150 degrees can be treated like the sine of 30 degrees, since it's 30 degrees away from the x-axis, or 180 degrees. Using all students take calculus, or of course knowing that sine is equivalent to the y-coordinate, and being in quadrant 2, the y-coordinate is going to be positive, we would know that the sine of 150 degrees is positive. And then using our knowledge of special right triangles, in this case we'd have a 30, 60, 90 right triangle, we would be able to conclude that the sine of 150 is 1/2. And of course, if you checked in the actual diagram, you can see that that is the case. Let's do some practice problems. What is the cosine of 0 degrees? We know that the cosine is going to be the x-coordinate, and we're starting at 0 degrees. So on the unit circle, we start out at the point 1, 0. So the cosine of 0 has to be 1. What is the cosine of 210 degrees? So I'm going to draw our coordinate plane here. And we'd be going 210 degrees. So 90 degrees, 180 degrees, and then an additional 30 degrees. So that'll take us to about here. We'll draw out a triangle. So at 210 degrees, we know that this angle here from the x-axis is 30 degrees. This, of course, is a right angle, so this has to be 60 degrees over here. We know that the sine is going to be the y value, so this is going to be the sine on this side here. We know that this is the hypotenuse with the radius 1 since we're on a unit circle, so then the cosine, of course, has to be this distance right up here. So the cosine of 30 degrees, we know that we have a unit circle, and we know that we're going to have a special 30, 60, 90 triangle. So if the hypotenuse is 1, that means the side opposite, or the sine, is going to be 1/2. And then we know that the side adjacent to the 30 degrees is going to have to be the square root of 3 over 2. We also know that because we're in quadrant 2, in all students take calculus, only the s, or sine, is going to be positive, so the cosine has to be negative. So we must be at negative square root of 3 over 2. What is the sine of 0 degrees? Again, we're starting at the point 1, 0. Sine is going to be the y value, so the sine of 0 is going to be 0. What is the sine of 330 degrees? Again, I'm going to draw our axis here. So we have 90 degrees, 180 degrees, 270 degrees, and then another 60 degrees to get to our point. So that is going to give us an angle of 30 degrees from the x-axis. So that's going to be 30, this is 60, and it's a 30, 60, 90 triangle again. Sine is going to be this side over here. So we know, again, that the sine of 30 has to be 1/2, because it's a special right triangle with the unit circle radius 1. But we also know that we're in the 4th quadrant, so only cosine is positive in the 4th quadrant, so instead of 1/2, we have negative 1/2. What is the tangent of 315 degrees? So if we remember, one of the ways that we can evaluate tangent, rather than just use opposite over adjacent, so tangent of an angle theta is equal to sine theta over cosine theta. Tangent of 315 degrees is 45 degrees away from the x-axis. So really we're taking the tangent of 45. Or we can also take the sine of 45 over the cosine of 45. With a 45, 45, 90 triangle, we know that sine and cosine have to be the same. So that means we're taking a value over itself, so that means the tangent of that has to be 1. Of course, we're in the 4th quadrant, so using all students take calculus, we'll notice that in the 4th quadrant only cosine is going to be positive, so this has to be negative 1. Finally, what is the tangent of 150 degrees? So again, I'm going to draw out our axis. 150 degrees, so we're going to go 90 plus an additional 60. And of course, that's going to give us another 30, 60, 90 triangle. So 30, 60, 90. Radius or hypotenuse is 1 because we're on a unit circle. So that means this side has to be 1/2 because it's opposite the 30. And then the adjacent to the 30 has to be the square root of 3 over 2. And cosine is the x-coordinate. We know that we're in the negative, so it's negative square root of 3 over 2. And for tangent, if we take sine over cosine, we'll have 1/2 over the negative square root of 3 over 2, which simplifies to negative square root of 3 over 3. And we know this should fit with all students take calculus. In the 2nd quadrant, only sine is going to be positive. So again, this should be negative, so negative square root of 3 over 3 is correct.